Video on 9.3. I'm just going to show you one of these examples. These are word problems. Again, there's a couple of keys to success to be able to do these correctly. These are my recommendations. If you want to do well on the test, I would highly, highly, highly recommend doing that. These are going to avoid some of the common pitfalls that are, problematic for students as they go through this, unit into quizzes and tests. And so those things are, number one, annotate the question. I'll model all of these. I want you to write the equation and then include those units in the equation. That'll avoid, some of those errors that we see. And then at the end, I want you to check your work. And so I'm going to go ahead and do number 13. It's a little bit more of a challenging one, so that'll kind of help you out there, hopefully by doing that one. So step number one, I'm going to annotate the question. What I mean by that is I'm going to write on the question. So it says find the temperature. So I know that I'm looking for a temperature of a 500 centimeter cubed sample of gas at 5 degrees Celsius. Well, 500 centimeters cubed, that is a volume. We're going to call that volume 1. And the sample of gas is 5 degrees Celsius. So that's going to be temperature 1. And I know that from watching the other videos and doing a lot of these things, I know that I can't keep that in 5 degrees Celsius. That's got to be added to 273. So 273 plus 5 is 278 Kelvin. And 1 atmosphere is P1. Okay, so we're dealing with a volume, a temperature, and a pressure. Don't freak out yet because you're going to see something that's true here in a second. So we know that temperature must be heated, so we know we're going to increase temperature in order to achieve a volume of 2. Volume 2 is 1.5 liters at 1 atm. And what you should notice, if that's the second pressure, these two pressures are the same. And so we can ignore pressure as a variable. Pressure 1 and pressure 2 are both the same. So we can say that pressure is not going to change at all. So now we're just dealing with temperatures and volumes, right? We have a volume 1, we have a temperature 1. That means this must be temperature 2, right? So we know that, these things are going to pair together. And this is going to be a little bit of like a reading comprehension thing. It says 500 centimeters cubed sample at 5 degrees Celsius. So I know that those are both going to be like the same thing. So that's temperature 1 and volume 1. We're given a new volume. We need to find the new temperature. So those are both going to be 2's. So this is going to be Charles's law, which is what 9.3 is all about. We have volume 1 over temperature 1 equal to volume 2 over temperature 2. And now I'm going to plug my things in. It says volume 1 is 500 centimeters cubed over our temperature 1, which is 278 Kelvin, equal to volume 2, which is what we're going to, 1.5 liters. And what we're looking for is temperature 2. And again, if you follow my recommendations above, have we annotated the question? Yes. Have we written the equation? Yes, I wrote V1 over T1 equals V2 over T2. Have we used the units, right? Not just the numbers, but the units in the equation? Yes. And when you do that, it'll scream at you and say, wait a second, something's not right, which is why I tell you, number 3, to include units. Had you not included units, and you just rolled with it, right? You would have just rolled with it and life would fine, but you would have got the answer question totally, totally, totally wrong, which means obviously a lower grade. So at this place, we have to make one of these, either I have to make this into liters or I have to make liters into centimeters cubed. I'll just go ahead and make liters into centimeters cubed. So 1.5 liters, let's go and do a conversion here. I know that the standard is 1 liter, and the standard for centimeters cubed is 1,000 centimeters cubed. So if I go ahead and do that, that would be 1,500 centimeters cubed. And I can go ahead and cross off my liters. And that's how we do the conversion. So I'm going to get rid of this right here, and I'm going to replace that with 1,500 centimeters cubed. Okay. And so then what we're left with is we just have to do a little bit of algebra. You might have learned in math class that this is going to be a situation where you need to cross multiply. You might even draw yourself like a little butterfly, put a smiley face on it, but we need to do cross multiplication when it comes down to it. And so what I need to know is these two things need to be multiplied together and these two things need to be multiplied together. So I'll go ahead and start doing that. We have 500 centimeters cubed times T2, and that's going to be equal to 1,500 centimeters cubed multiplied by 278. I need to get my T2 by itself, so I'll divide both sides by 500 centimeters cubed. If I do it on the left, I got to do it on the other side, on the right. That's 500 centimeters cubed. I can cancel things out. 500 centimeters cubed is going to cancel over here. Centimeters cubed is going to cancel over there. And so what we're left with is 1500 times 278 equals divided by 500. And what we're going to see is T2, which is all that's left over here because everything else got canceled, is going to be equal to 834. All the units are canceled except for the unit I didn't actually write, which is Kelvin. I wrote it over here. For some reason, I didn't transfer it. So that's 834 Kelvin. Go ahead and circle your answer. If you have done all of those things, right, you should hopefully have the right answer. How do I double, triple, quadruple check? Well, plug that number back in. So what we should see is 500, I'm doing this, 500 divided by 278, I got 1.79, so 1.8 approximately. And then I'm going to take the 1500 divided by 834, and I got the same number. So if I plug these in, this is about 1.8 on this side, and then if I plug in that value right there, it's going to be equal to about 1.8 over here. I plugged it back in. I know I didn't make a mistake algebraically, and so if you do those things, you annotate, you write the equation, you use the units. That'll prevent you from making a mistake where you have liters over here and centimeters cubed over here. And then at the end, if you check your work, if you do all those things, you're going to have a very, very, very high likelihood of getting the question right, which translates into a very, very, very good grade. If you have any questions, please let me know. I hope this was helpful. Have a great day.